Welcome back, everybody. Again, my name is Wally,
I'm Jason.
and today we're going to talk about compass errors. When is a compass accurate in an airplane?
Probably sitting on the ramp.
Yeah, not very often. When you're flying around, if you're looking up at that compass, it's probably dancing all around. I'll ask my applicants on CFI or CFII and instrument check rides. I'll say, when is the compass accurate? And the answer I get 95% of the time is straight and level flight.
That's one half.
And I'll say, what else? Well, straight and level flight. Yeah, they're missing something. There's another word, and that word is
Unaccelerated.
unaccelerated. Straight and level unaccelerated flight. Now, me growing up, getting my instrument rating a long time ago, really long time ago, I struggled with all these compass errors, and I was able to be very successful in my instrument training by learning how to do time turns.
That's another half. Yep.
And so we'll kind of go into that just a little bit. If you look at your turn coordinator, what does a turn coordinator typically say on it if you're in an airplane that has one?
It'll have obviously the cardinal directions, so northeast, southwest. It'll also have the 45s, the little hashes.
So
for
what does it
45.
say when down there where there's some words on it? What are the words typically on a turn coordinator? 2 minute.
Oh, yeah. Okay.
The letter, or the number 2, the digit 2, MIN. What does that mean? It means it takes 2 minutes to go all the way around 360 degrees. So if we do some math here, again, we're going to have to take our shoes off to do this one. 360 degrees divided by 2 minutes is 2 minutes is 120 seconds, 60 times 2. So we do 360 divided by 120. That is, or do 36 divided by 12. It's 3.
It's 3, my lord. 3.
Yeah.
It's 3. 3, my lord. You remember that from
Yeah.
Shrek? 3,
Yeah.
my lord. 3 minutes. 3 seconds, rather.
So it takes 3 seconds to go a degree. So if we need to turn 30 degrees, 30 divided by 3, it's going to take us 10 seconds. This is not an exact science, folks. So how long is it going to take to go 10 degrees? Don't say 3.3. Say 3 seconds.
3
Okay?
seconds.
It's going to take 3 seconds.
But how do you do that? Let's talk about that. So it is, all right, we want 10 degrees left or right. I don't care. Just go 10 degrees somewhere. It is once you're at your standard rate. Everything is based on standard rate.
Right.
You got to go to standard rate and then count 3 Mississippis, go wings level.
Exactly.
That is your 10 degrees.
And then at that point, take a look up at the compass and see how you're doing. You're going to be really, really, really close.
Correct.
So, and that's how I did it. If you know, I was able to say, okay, if we're on a heading of 070 and we need to turn to 140, I could, in my head, I could say 70 to 140. That's a 70 degree difference. And so I know 20 degrees is going to, or 60 degrees is going to take me about 20 seconds plus another 3. So I put it in that bank and I hold it there for 23 seconds. And, you know, obviously I passed the check rides and that's basically how I do it.
So time turns. I approach this a little bit different, right? So we talk about, and we will in just a second, but how I approach this, I'll talk about the errors, the magnetic compass errors, right? So everybody knows it's DV Mona, right? So deviation, variation, magnetic dip, oscillation, and then it's unos and ands, right? So those are your errors. Those, and then I'll give some examples, right? Those are a WAG, right? That's going to get you kind of in the ballpark.
Right.
The more precision is actually the timed turns. So between the two of them, you kind of have it, you know, dead on center, right? So that's kind of how I look at it. So how do you know what your error is. So real quick, what he's talking about, straight and level unaccelerated. That unaccelerated, that's the ANDS. That's ANDS. That's your DV MONA. That's the A in ANDS. That's when do you set your compass? When do you set your DG, your heading indicator, whatever you want to call it, whatever you have? That is straight and level unaccelerated flight. So starting with an A, that is accelerate north, decelerate south. So if you accelerate, your compass is going to swing to the north.
Right.
If you pull the power back and you decelerate, your compass is going to swing to the south. So this is one thing which the newer, not generation, it's the people flying the newer aircraft. If you have Garmin 275s, G5s, those AV30s, G1000s, basically if you have anything digital, nobody knows when to set your heading indicator to your compass, because you simply don't have to do it.
Right.
And then back in the day, do you remember when stuff was slaved, the slave gyros, right? None of that, I can't say none of it, it's rare now.
Yeah.
Right. So it's kind of a lost art. I did a private check ride, and we did steep turns, we did all maneuvers, we did unusual attitudes. Well, one of the errors on a heading indicator is it's gyroscopic. So when you're getting other than normal maneuvers, that heading indicator, it's gonna I want to say skip, that's not it, it's gonna tumble. So it'll spin. So we, at the end of that, it was all right, let's take me to Huntsville Airport. And he went direct enter on his GPS, and he went and turned to the head, and let's just make it easy. Let's say it was turned to heading 180 to go to Huntsville. But because his heading indicator was gyroscopic and he had not reset his heading indicator to the magnetic compass, straight and level unaccelerated, he hadn't done it in a while, what he thought was 180, because the heading indicator had tumbled, what he thought was 180, lack of, just to make it an example, we were legitimately flying, just say west. We were way off. So he was actually flying away from the airport because he hadn't reset the compass. Yeah. So these instrument ratings, right? This is a rating, and this is why when we do partial panel, when we do that, you're not getting a type rating in that airplane. It's a generic rating, meaning you're supposed to be able to fly any avionic, any equipment. You're supposed to be familiar with all of it, right?
Right.
So that's kind of a tangent on when do you set your heading indicator, your directional gyro. But I always start with the errors, and then I go to the time turns. So the errors on a magnetic compass are deviation. What's deviation? That's your D and DV MONA. That's stuff, magnetic interference, when the radios are on in the airplane. So you have your compass deviation card.
Right.
It's typically one. I've never seen it more than 3 degrees. It's very small.
Right.
But there's an error nonetheless.
Right.
So that's your deviation. What's variation?
Variation is what we talked about. That's the difference in magnetic north and true north.
Bingo. So how is that depicted on a sectional?
Isogonic lines.
So that's the dashed magenta on a sectional. Those are called isogonic lines. Those depict variation. So then a lot of guys and girls have when they go instrument, they have the NOS, the government charts. Variation is actually on those low and route charts. It's a solid green line. It's a very thin green line. The difference between those is on the low and route charts, on the NOS charts, there's only whole. There's not 1.25. There's no quarters, there's no halves. So it only depicts whole degrees of variation on the low and route chart. And there's actually no variation on a Jeppesen low and route chart. It's just not, they just choose not to do it. But that's variation. So that's different, true and magnetic. Magnetic dip, very simple. As you get closer to the poles, the compass will start to dip towards the pole, right? So there's tension, there's angle on that. It's just another error. Oscillation, this is actually a fun one. You actually started it out. You're sitting there looking at your compass and it's bouncing around.
Yeah.
Why is it bouncing? Because it's oscillating,
Right.
because it's sitting in a liquid,
Right.
which brings up the follow-on question, what kind of liquid?
Well, I've heard people call it a whiskey compass, so I'm guessing that maybe there's some alcohol involved there.
Maybe. Well, that's more of a did you know what the compass liquid in, and I actually have it in my office. I let them smell it. It's actually kerosene, right? It's clear, it's highly viscous. So if you've ever touched kerosene, it's actually almost slimy,
Right.
right? That's what's in a magnetic compass. It's clear. So I'll ask back in the day, or when I'm asking what's in it, a lot of them will say water, and I no.
Yeah.
So then inevitably whiskey compass will come up.
Yeah.
So I'll ask why back in the day did they call it a whiskey compass? Maybe the pilot wanted some whiskey, and I'm like, well, I'm not flying with that pilot.
Yeah.
But basically, why was it called a whiskey compass? It didn't freeze.
Right.
It's very simply, it doesn't freeze.
Yeah.
So whiskey doesn't freeze. Obviously, it's a liquor, but it would be actually more appropriate if it was like a tequila or a vodka or a gin compass, because it's actually clear instead of brown.
Right.
But none of those sound near as cool as whiskey compass. So I think that's where the whiskey came from.
I think we should start a thing and start putting worms in compasses. We could call it a tequila
I
compass.
do not like tequila.
Yeah.
Anywho, but that's why it was called, the nickname was a whiskey compass. You can't put water in it simply because it would freeze.
Yeah, and think about that. I mean, airplanes sit out in the winter, even in Texas, that we get freezing temperatures.
Yeah.
But how do those airplanes up in Alaska work if you got water in the compass?
This is just going to Dallas,
Right.
right? But that's just it. So the oscillation is there simply because it's sitting in a liquid, right? So it bounces around. You're a buoy and you're a boat on the ocean, right?
Right.
Next is UNOS. And this is kind of where it gets interesting. This is where the diagrams come into play. UNOS, right? That's the N for DV Mona. It's undershoot north, overshoot south. So because of built-in errors, if you're turning towards the north, you're going to have to undershoot that. If you're turning towards the south, you're going to have to overshoot that. Why do you undershoot? Simply towards the north, the compass is going slower than you because initially it turns the other direction. And then going towards the south, you have to overshoot it. Undershoot, it's going faster than you. Overshoot, it's going slower than you. What do you undershoot or what do you overshoot by is based on your latitude. So where we are, I think we're about 30, 33. I'm just going to call it 30. So if you were to want to go from north and turn south, the smart person would be like, well, I'm just going to time it for a minute. And I said, oh, well, your clock's broke, right? So I want you to do it the old way. So you're going to have to overshoot south. How much do you overshoot by? Approximately 30. So you're going to turn right, and when you get to see 210 on your magnetic compass, go wings level, and it should ballpark out about that 180. It should go to 180 based on your latitude.
Right.
And this is what Wally was talking about earlier on the timed. It's if you're 10 degrees off, okay, fine. So if you roll out and it says 190, turn left, go back to your timed turns, turn left, standard rate, count to 3 Mississippis, go wings level, you should be at 180.
Right.
So the compass turns, just the overshoot, undershoot, that's a ballpark, that's a wag. You can use timed to kind of fine tune it, or just use timed turns. One of the bigger flight schools, they had brand new Archers. There was actually the Mirage that I fly, there is no magnetic compass.
Yeah.
They have an Aspen for the standby.
Right.
So for a while there, this skill set of time turns had gone away because there was simply no magnetic compass installed in the aircraft.
Yeah.
Instructors, if you're listening, do yourself a favor. This is maybe literally a 10 to 15 minute lesson in the airplane, and they just have to see it kind of once or twice. Ask the question, have them demonstrate it, or you demonstrate it, then have them follow you, and that light bulb will go off. This is a skill set that's diminishing because everybody thinks GPSs and AHRs and all that stuff is never going to fail.
Right.
Oh, it's going to.
Yeah.
It's just when, and hopefully it's not you, but this skill may come back and just knock the cobwebs off. But at least you guys have done it.
Yeah. Yeah.
Right.
Yeah. It's as he said, you see it in the airplane, and it's definitely a light bulb moment.
Let's close with this. So obviously, if you're turning north and I say turn to some southern number, you're going to overshoot because you're turning towards the south. Turn to the north, you're going to undershoot. So when is there no errors on a magnetic compass? When it comes to time, when it comes to turning. What if I said, Wally, if you're heading north, I want you to turn right and roll out on east.
Yeah.
Would you undershoot or overshoot anything there?
Neither one.
Neither one. Why?
Because you're halfway in between.
There is no errors east and west, right? So that straight and level unaccelerated, that's when you set your compass, right? But if you want to roll out on east or roll out on west, you roll out on east there are no compass errors going east and west.
Right.
It's only north and south.
Right.
So it's not a trick question. But if I say I'm heading north, take a right, I want you to roll out on east, right? Because you're turning, so you don't overshoot or undershoot. You simply roll out on east. It finds itself and it makes itself right.
Right.
It has to break that north-south plane in order for the error to come back into play. Would you agree?
Yeah. Now, if you're on east and you're going to a heading of 045, there is some error, but it's not near as what it would be all the way to the north.
So 045, if everybody wants to do some time turns, you're going to go standard rate, count to 15, and guess what? You're going to roll out on 045.
Yeah.
So this is where, just a little bit in the background, it truly, truly helps. But again, the key to this is standard rate, not 10 degrees, not 20 degrees, 15 degrees. So find that and hold it.
And instructors, those of you who are teaching in six-pack airplanes, I had 3 vacuum pump failures very early in my flying career, so I was used to flying around without a DG, and I actually got pretty good at it. And so when I became a double I mean, probably this isn't an exaggeration, but I'd say 45 to 50% of the time that we flew around under the hood, we were partial panel, because it happened so often to me.
That's a whole other. We could talk about what partial panel is, but no, in a G1000 when we do partial panels, you cannot hit display reversion. We are simulating a system failure, not a display failure.
Right.
So if in a check ride with me, if I fail your attitude and you go display reversion and put it over, I'll go nope, unable. Right. And same with G5, same 275s. If I cover up your attitude, I'm simulating an attitude indicator or a vacuum failure. Just your attitude tumbled, it's gone.
Right.
That is what we are simulating. You cannot revert to the bottom G5.
Right.
Yes, I understand it's going to happen, right? But again, you're not being typed in that aircraft. This is a system failure. In the G1000s, we will simulate AHRS failure. So your comms are going to work, and the only thing you're going to lose your outside compass, but you'll have your inside needle.
Right.
So go look in the POH, and you'll see X's and what works and what doesn't work. But that's how you should, quote, should be training. Don't take the easy way out, because when it fails, you need to know what to do.
Yeah.
So there's a little soapbox.
Yeah, yeah. All right, well, that's it. That's our compass error lesson for today. So if you'd go down the bottom, hit like and subscribe, tell your friends about us. Here are our email addresses again. If you got any questions, any comments for us, if you've got something that you'd like us to talk about, we'd love to hear from you. And I guess that's it for today.
Cool. Copy that.
We'll see you next time.
Have a good one.